I'm speaking to you all the way from Scotland. I thought I'd show you a little number trick, or maybe two. We'll see how we get on, right? At a buffet, you're meant to have some food, right? So I've got some fruit here, right? And I've got, let's see, there's a pineapple, an apple, a banana. There's a melon. There is a lemon and a lime as well. Anybody want to maybe suggest one of those fruits that I'll use as part of this weird...
Banana.
Banana? Was that banana?
Pineapple.
Oh, pineapple. Sorry, right, okay, the big pineapple. Of course. There it is, right, the pineapple's here. And we'll use that in a wee minute, right, okay, but thanks for that suggestion. So what I'm going to need to do just now is I'm going to ask you, maybe one at a time, I'll get you to go through each screen, and for you to tell me like a bunch of numbers. So you can choose whatever. I don't want to influence you at all. You can pick like numbers that are in your date of birth. It could be the number of bad jokes that you have written down somewhere. It could be the number of uncles that you have. It could be your I don't know, it could be just a favourite number. It could be just a string of digits. I don't know, right? But let's start with can we start with, I don't know, Jack? Do you want to give me some digits, Jack?
156 and 8.
156 and then an 8. Yeah? Okay, right, I've written that down. We're going to get a big number, basically. A big, unpredictable, Mr. Smith could never have predicted this in advance type number. 136, okay, 1036. There it is there. I've just bolted it on. Okay, so the number's getting longer. Now, that's just had 2 lots of 4 digits. It doesn't have to be like that, but if you want to, you can. Let me write down 1,005,000 first, right? So 1,005,000. So 1, 2, 3, 4, and then thank you very much. Now I do still have a wee bit of space. You can see it along my board. So maybe I could get some more. Who's going to give me one? All right, okay. I've got hands up. 52. Right. I have managed to squeeze that on. Are we happy with that number that you guys have constructed that, haven't you? That's not been made by me. I haven't forced this decision. This number, it might never. This is quite weird because this number might never have been written down before. If you think about it. You know, as numbers get bigger and bigger, maybe they've never been used for anything useful. And we've got this huge, huge number, right? You can see that there. Now, what we're going to do is, I need to know that you guys know a wee bit about odd and even numbers, odd and even digits. Do you know about odd and evens? Just give me a thumbs up if that's something that you're familiar with. Right, okay. So odd digits would be like the ones, the threes.
Number.
Say again. That guy knows what he's talking about. This is an even number because that last digit is a 2. But what we're going to do is we're actually going to do a wee, almost like a wee survey, right? Because I want to know how many even digits and how many odd digits our number has. Because it's got a bunch of evens and a bunch of odds, doesn't it? Right? So we're going to have to do a wee bit of counting. Now, maybe what I'll do is I'm going to score out, let's say, the evens, right? And you need to make sure that I'm not cheating, right? Okay? That I'm not just making this work, right? Okay? All of you, make sure that Mr. Smith isn't cheating, right? So all the evens, I'm going to score these out as we go. So, or maybe I'll just put a line through it so you can still see that it's there. Maybe that's fairer. Or maybe even put a dot at the top. That's all I'll do. Right, so here's a dot for an even number. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There were loads of them at the end. I don't know if you meant that. Right, so I've got 18 odd digits there. Okay? Did I cheat? No, I did not cheat. No. 18 even digits. And then we're going to do the odds. Now, they should be easy because it's just the ones that are left. So, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, only 11. Now, you kind of have to take my word for that because it's quite hard to see on a Zoom call. Yeah? If this was in a classroom, I'd be getting you out to the board and saying, you score them off. Basically, you should be doing all the hard work, not me. Yeah, not me. Right, so I have added up, I've worked out all the even digits, 18 of them, all the odd digits, there was 11 of them. Right, now, this number at the top, we all agreed, that was totally weird, totally random, might never have been seen by anyone before, and now we've got a new number, 181129, and I didn't pick that, and you didn't pick that. Right, so how many even digits do you see along this string of numbers? 2, yeah, because we've got an 8 and a 2, right, okay, good. How many odd? I can definitely see people getting this right. That's a big hands up for a 4. And then how many were there in total? Come on, you know that. 6, correct. This top number, totally weird, right? Okay, maybe the first time that number's ever been out in public gave us this. How many even digits do we have now? 3. How many odd digits? 0. That's a harder one to do with your fingers, isn't it? Yep. And how many in total? You guys are like reading my mind, like predicting the future, guessing what I'm going to ask next. What do you think we're going to do now? I've got a new number, 303. So, how many even digits? 1. How many odd digits? 2. Good, well done. And how many in total? 3. We've ended up with the number 123.
Can you keep going forever?
Number 1. Oh, let's try it then. Let's try it.
3.
Okay.
3. Right.
Why is it going to stay there?
Because there's still one even.
Oh yeah, we're going to get 1, 2, 3 again. Oh my goodness. So this we ended up stuck at 1, 2, 3, and I could keep going. And because 1, 2, 3 has got 1 even, 2 odds, and 3 in total, I'll end up stuck at that number. I'm never going to escape from that number. Now, this number that we started at the top, made up by you, right? I'm not to blame for that, made up by you. And we went through this weird process and we ended up with the number 1, 2, 3, chosen by you. Also chosen by you was 1 Scottish pineapple. I don't think it is a Scottish pineapple. You could never grow a Scottish pineapple, right? Okay, that's just not going to happen. But what I'm going to do is I'm going to cut open this pineapple. Right, and inside this pineapple is a little bit of, it's like a bag, and inside that bag there is a little number on a bit of paper. 1, 2, 3. Oh yeah, 1, 2, 3. I don't know about you. Pineapple maths for the buffet. Right, so, wow, that kind of, every time I do this and look at this wee number trick, I'm kind of amazed. And you might want to, later on, have a wee think about whether every number goes to 1, 2, 3, because do you not think it'd be a bit daft of me to get you all on here, do this trick, and then for it not to have been 1, 2, 3? That would have been embarrassing, wouldn't it? Yeah, you'd all have been like, we're leaving that. That would have been
very embarrassing.
Very embarrassing, right? Okay, you'd be like, this guy is rubbish, right? But actually, that always happens. And you maybe want to think about why that is. If we're always narrowing down to 3-digit numbers, then the end digit should always be a 3, but like we had a few numbers like that. We had a 303, and then we had a 1, 2, 3, but there are maybe other numbers to explore. Right, first, before I do that, I think Amelia's got a question or something really clever to tell us.
What if you try to do the number trick with the 2-digit number?
Right, that's a great question as well, Amelia. If you want to start with a number lower than a 2-digit number, you will find that you still get to 1, 2, 3. Because you'll end up putting zeros in one of the columns, and then you'll end up getting to a 3-digit number. You will still get to 1, 2, 3. But that's a great question to ask. It's always good to think when you've got a problem, can we think about a simpler case, or can we find, even more exciting, can we find something that breaks this rule? Can we find something that breaks the pattern? And mathematicians love doing that, right? That's called finding a counterexample. And so if you can do that, you're on your way to becoming something special in mathematics. So great question, love it, right? Now, can we prove it? Yeah. So that's what I'm saying. There are only so many numbers that we could write down that actually end in a 3. So for example, if we wrote down even, odd, and total. Now, let's ask you, right? Okay, if we know eventually we end up with 3 digits because we need to have one number in each column. Yeah. So if we're going to have 3 digits, that number at the end is going to be a 3. So someone tell me, what are the options for even and odd? Because there are a few different options. What could we have? What different types of combinations would give us?
1 and
Sorry,
2.
1 and 2. Someone give me another one.
2 and 1.
2 and 1. Yeah, we sure could.
3 and 0.
3 and 0. And
0 and 3.
0 and 3. And that's it. That's the options. So eventually you're going to get down to one of those 4. So what you can do with this is just literally check. If I had 2, 1, 3, what happens on the next step down? What happens? Will I eventually get to 1, 2, 3? And all you have to do is check that one, and that one. And actually, we already checked one of those. 303 does get to 1, 2, 3. So this is an example of something that you can prove exhaustively. That means you know all the options and you can just check them all one by one by one, and eventually you find what is going on. But let's do one other wee trick, which is one of my favourites. But it's one that this might be something that you've seen before, because this one's more common, I think, than the 1, 2, 3 trick, right? So don't give the game away if you already know this one, right? But I'm going to use a calculator for this, right? Okay, it might be that your brain is like a calculator, or you might have your phone, or you might be using it on your computer, but you might want a wee calculator handy for this bit. And what you're going to do is you're going to start by picking your favourite number between basically a 3-digit number. Right, so we've been talking a lot about 3-digit numbers. I've been doing this 1, 2, 3 trick, and we've talked about 303 and 246 and lots of different numbers. I want you to pick your favourite 3-digit number. And I'm going to go for 1, 2, 3 since that's what we've been using up until now. You go for a different number. Don't tell me it. Don't put it in the chat. Don't hold it up. Don't do anything. You just keep this to yourself. But if you've got a calculator, that'd be great. Right, okay? I would say a calculator is the best plan for this. Great, I can see some people holding up calculators. But remember, don't show me the screen because I don't want to see your answer. Right? So, I'm going to pick the number 1, 2, 3 and I've typed it into the calculator. And now, what I'm going to do is, seems a bit boring, but I'm going to type that number again. So, that's going to give me 1, 2, 3, 1, 2, 3. So, instead of a 3-digit number, I've now got a bigger 6-digit number. So, that's why calculator might be handy for this. Right? So I've got 1, 2, 3, 1, 2, 3, but you'll have something else. Your number written basically twice. Okay, so thumbs up if you've got a 6-digit number now. Excellent. Now, I think I forgot to mention that this number is that we're going to aim for, it's to be in the 13 times table. Did I forget to mention that? Uh-oh. Right, well, let's try it. Right, divide your big 6-digit number by 13. This is another reason why the calculator's helpful. Right? Dividing by 13, like on the spot in a Zoom call. That's tough. Right? Oh, divide by 13. I hope it was in the 13 times table. Yeah? Oh, it was. Great. Oh, well, a few thumbs. Wow, loads of them are in the 13 times table. Right? That answer that you've got, I want you to divide it by, this will need to be in the 11 times table. Right, let's hope this is in the 11 times table. Divide by 11. Put your thumbs up. Yeah, some people are putting their thumbs up. So we've managed to find something in the 13 and the 11 times table when I didn't even tell you that in advance. Amazing. And last thing I want you to do is I want you to divide this final bit that you've got in your calculator by 7. No, I didn't tell you it was to be in the 7 times table, but we'll try it. Divide by 7. And have a look at your calculator. Have a look at your calculator. Does that number in your calculator look familiar? Is it 1, 2, 3? I got 1, 2, 3. Did you get 1, 2, 3? Someone tell me. Someone tell me what they got.
Yeah, I got it too.
You got 1, 2, 3. Did you pick 1, 2, 3? Same as me. Did anyone pick a different number to start with? Okay, Jack, what did you get? Oh, we're not mute. We're still muted. Whoops.
We got 356, and we started with 356.
Wow.
Oh, so they didn't even start with the same number, but they ended up back where they started. How cool is that? That's amazing. So, this trick, okay, I want you to, this is your homework. I can't believe you get homework. You come to like a nice, friendly, let's see some tricks, and I'm giving you some homework. You have to go and you have to try this out on some folks at home or some friends, or the next time you're on a Zoom call. I want you to ask someone to pick a 3-digit number, to type it into the calculator twice, and to divide by those 3 special numbers. I wasn't choosing them at random. And I knew that your number, your big 6-digit number, was going to divide by 13, 11, and 7. Right? And then that will always get them back to the number that they started with. And the reason for that is somebody's got a hand up. Does anybody know? On you go.
One thing I noticed is that they're primes.
Excellent.
Does that have something to do with it?
That is a fantastic observation, right? They are prime numbers, and that is definitely something. There's something sneaky going on in the background of this problem, and it's to do with the primes. So dividing by 7 and dividing by 13, then 11, then 7 is the same as dividing by what single number? Could we have got there in one single step? Oh wow. That's definitely one to think about. Can anyone figure that one out? We're dividing by 13 and then 11 and then 7. That's the same as dividing by one single number.
Is it dividing by 31?
Why do you say 31? That's interesting.
If you add all the numbers together, you get 31.
Okay, so you're so close. We do need to combine those 3 numbers, but we don't add them, right? Because we think if you're doing dividing by. Yeah. Oh, sorry.
Times?
Yeah. So what happens when you multiply 13 by 11 by 7?
You get 101.
1,000. 1,001. And so if you take a 3-digit number and you multiply it by 1,000, well, you get that number of thousands. And if you multiply it by 1, you get that number back again. And so you end up with, for example, 132,132 or 314,314. And so what's going on there is we're working that in reverse. And so, but we disguise it. We don't just say divide by 1,001, we say divide by 13, then 11, and then 7. Right, so that is what's going on with that puzzle, and you've pretty much cracked it yourself. So that is brilliant. Your brains are thinking in exactly the right sort of ways, right? Identifying prime numbers, trying to figure out how we combine these numbers to get the secret code to what's going on. And so you have done some brilliant maths today, some superb number work, and I'm really impressed with you lot. And thank you very much for having me. I've got to go now, but it's been a delight to chat to you this evening, and I hope you have a super rest of the session.